Hi, welcome back to Mrs. Thompson's classroom again today. We're continuing in our unit on trig identities, and today we're going to look at the double angle formulas. So here they are. If we have sine of a double angle, it's going to equal sine of 2 times sine of x cosine of x. Now cosine has 3 different versions of it. And so let's pay attention to that. But I want to show you where these come from. So let's think back to our summation formulas. So sine of 2x is like sine of x plus x. So according to our summation formula, this would be sine of x cosine of x plus sine of x cosine of x. So that is twice sine of x cosine of x. So that was pretty straightforward. Cosine of 2x is also like cosine of x plus x. So I get cosine of, x cosine of x minus sine of x sine of x. So this equals cosine squared minus sine squared. So that's the first version of this identity here. Now using our Pythagorean identity, the Pythagorean identity says that sine squared plus cosine squared is always equal to 1. So this means that sine squared would equal 1 minus cosine squared. So I can replace here and get cosine squared minus 1 minus cosine squared. Distributing that negative through the subtraction, I end up getting 2 cosine squared minus 1, and we get the second version. But the Pythagorean identity also tells me that cosine squared is 1 minus sine squared. So if I take and replace here, I'll get 1 minus sine squared minus sine squared. And so that's 1 minus 2 sine squared. And I get the third version. Now when we're solving equations or verifying identities, the version of cosine of 2x that we use depends on whether what I'm using has both sine and cosine in it, or whether it only has sine, or whether it only has cosine. So there's a different purpose for all 3 of those versions. All right, so let's take a look at how we use these. So we know that sine of 2x, our formula for that is 2 sine of x cosine of x. So let's look at what they tell us. They tell us that cosine of x is 2/5. So I can replace cosine of x with 2/5. Now that also tells me that cosine squared plus sine squared is equal to 1 by the Pythagorean identity. So cosine squared is 4/25. So that tells me that sine squared is equal to 1 minus 4/25, which is going to be 21 over 25. So then I can take my square root, and I get sine of x is going to be equal to, fix that there, the square root of 21 over 25, which is equal to the square root of 21 all over 5. Now, taking the square root would give me a plus or a minus, but it tells me I'm in quadrant 4, which means that the cosine is positive and the sign is negative, so I will keep the negative sign on here in quadrant 4. Okay, but that means I can come and now replace sine of x with negative square root of 21 over 5. And then don't lose the 2 in the front. And so I get 4 square root of 21 negative over 25. Because this 2 is like 2 over 1. So we just multiply across the top and multiply across the bottom. Okay, now cosine of 2x. I could go back to my Pythagorean identity since I found the sine of 2x. Or I can remember that this is cosine squared minus sine squared. So I found my cosine value, so I'm going to put that in here. They gave me my, sorry, I just put that in backwards, hold on. They gave me cosine, which is 2/5. We found sine, which is negative square root of 21 over 5. And if I square both of those, I get 4/25 minus 21/25. So I get negative 17/25. Okay. Now you could have, since they gave me cosine, maybe you want to use this version. And that would be twice 4/25 minus 1, okay, which is 8/25 minus 1, which is still negative 17/25. So any of the 3 versions of cosine of 2x would work. I could also do sine squared of 2x plus cosine squared of 2x equals 1, and I could use my Pythagorean theorem and figure out what that is. So they gave me sine of 2x. We already found up here. So that would be, if I square that, that's going to be 4 times 21 over 25 squared plus cosine squared of 2x equals 1. And you could solve it out and still get 17/25 negative. Now, if you did it that way, you'd have to take the square root and you'd have to remember what quadrant you're in. So this version is not as straightforward. It's better to do one of these. Now, to find tangent, we simply put them over each other. So sine of 2x over cosine of 2x. So that's going to be negative 4 square root of 21 over 25 divided by negative 17 over 25. So the 25s are going to cancel, and the negatives are going to cancel, and we end up with a positive result. Okay. All right, let's do another one. So this is set up like my cosine of 2x. So this is going to equal cosine of 2 times 5 pi over 12, which is equal to cosine of 5 pi sixth. Cosine at every pi sixth is square root of 3 over 2. But let's remember our unit circle. Pi is over here. This is 6/6. So 5 pi sixth is over here. So that's going to be negative when I take the cosine value. Okay. All right, now if we rearrange these formulas, we get what are called the power reducing formulas. Okay, so we're going to take those and lead them into our half angle formulas that we do in my next video. But these are useful as well because I can take a sine squared and get back to something that is not squared, or a cosine squared and I can get to something that is not squared. And so these are going to be useful, especially when we start get into our calculus and we're trying to do derivatives and integrals, because I won't have that square on there anymore and it becomes easier to do. So we'll get a little bit more use of that later. Okay, but hopefully I will see you next time. If you need some more examples of this, we'll look a little bit closer in class, or if you are just out there on the internet somewhere and you're watching this, you can be sure to comment below and tell me what you think, and I'll get back with you. Thanks for joining us. Bye-bye.